become more frequent. My name is Vezdana Stojmirovic, and I am Associate Dean of Design and Media. And it is my pleasure to introduce to you Helen Armstrong, who is going to deliver an amazing lecture entitled Big Data, Big Design, Why Designers Should Care About Artificial Intelligence, a very hot topic for all of us. And it transgresses just design, it's for creatives of all types. I'd like to quickly just thank the Provost's office, Provost Tiffany Holmes, and Vice Provost Colette Vise-Colors for making this lecture possible in these uncertain times. And so by way of introduction, Helen Armstrong is a professor of graphic design at North Carolina State University. She focuses her research on accessible design, digital rights, and machine learning. Armstrong authored graphic design theory while she was a graphic design MFA student here at MICA. Woohoo! Graduated 2009. Sorry, veering off your intro. And also digital design theory, readings from the field. And she co-authored Participate, Designing with User-Generated Content with Your Humble Servant. Her new book, Big Data, Big Design, Why Designers Should Care About Artificial Intelligence, demystifies AI, specifically machine learning, while inspiring designers to harness this technology and establish leadership via thoughtful, human-centered design. She's a past member of the AIGA National Board of Directors, the editorial board of design and culture, and a former co-chair of the AIGA Design Educators Community. And NC State named her a university faculty scholar in 2018. She holds an MA in English literature from the University of Mississippi, an MA publication design from the University of Baltimore, and an MFA in graphic design, as we mentioned, from MICA. Her work has been recognized by Print and How and included in numerous publications, too numerous to list here. It is my delight to present to you Helen Armstrong.
Thank you, Svaz. That was great. So I am really happy to be here. It's been a long time since I've been back, not here, but anywhere. I've been stuck, behind a screen like everybody else. So it's really fun to be here. Okay, so I will go ahead. I will begin. So what I'm going to talk to you about today is why designers should care about artificial intelligence. But before I jump into that, I have to unpack a little bit what I mean by artificial intelligence. So when I say artificial intelligence, I really mean machine learning. Machine learning is the most prevalent form of artificial intelligence today, and I'll talk a little bit about why. But what machine learning is in essence a set of algorithms that analyzes data, detects patterns in the data, and then makes predictions. And that word prediction is really important. It's not truth, it's a prediction. Okay, so we might predict, for example, whether or not an email is spam, whether or not the sentiment behind a block of text is predicted to be mad, happy, sad, confused predominantly. We might predict the identity of a face. We run across machine learning constantly in our lives. For example, we might be streaming a movie or a series, and there might be a prediction about the next, you've liked these things, so we're predicting you're going to like this other thing. It might be music, a product, a show, anything that is involved in a recommendation flow. So we also run across machine learning when we're using Google Maps or Lyft and there's an ETA. We experience machine learning when we get a fraud alert or on our credit card. As we move through a Google search experience. So we're interacting with this technology quite frequently as we move through our days. Another way to think about machine learning is to differentiate it from traditional programming. So with traditional programming, we input commands, line by line commands. With machine learning, instead of inputting code or inputting commands, we're inputting training data. So for example, rather than arduously writing out line after line of code to try to differentiate between to create an application that might differentiate between two varieties of snakes, which would probably be very brittle and very time consuming. Instead, we might feed a set of algorithms, our machine learning algorithms, a whole bunch of labeled images to represent copperhead snakes, and a whole bunch of labeled images to represent red rat snakes. And then we would let the statistical model or the algorithms themselves determine the difference between those two snakes, so that any images we now feed into the system are going to be put into one of those two buckets. And I will add that those are the only two buckets. So if you put a picture of me in there, I would also be placed into a copperhead or a red rat snake bucket. I'm not sure which. Okay, so why is machine learning growing more increasingly prevalent in society right now? So first of all, as I mentioned, machine learning works through the input of training data. And we need a whole lot of training data. And conveniently, we are producing a whole lot of training data right now, a whole lot of data. As we move, imagine your own life in the last week or day or hour. You have generated a huge cloud of data, right? You may have just gone online. You may have driven through a traffic camera. You might have bought something. You might have checked your email, watched something online. The list goes on and on. So we're generating this big cloud of data, and the decrease in cost of sensors and detection devices have allowed us to capture all that data. But all of that data would not be useful if we did not have the compute in which to process that data. And by compute, I mean innovations in chip design, network architecture, and cloud-based resources. This number I find kind of astounding, that as of 2018, the compute was 300,000 times larger than it was in 2012, 300,000 times larger. So we have the processing power to analyze all the data, and we have the data. And for these reasons, it makes sense for machine learning to move to the forefront of AI technology right now. As the cost of machine learning drops, it will become even more prevalent in our society. And as it becomes more prevalent, as it moves through different sectors, we will see it impacting us more and more. An example of this we can look to is electricity. So in the early 1800s, electricity was 400 times more than it does today. And so as the cost dropped, it spread throughout society, and society began to change as a result. We started working night shifts. We started building rooms in the interior of buildings with no windows. Our culture began to change as a result of the technology. And anyone who is a Gen Xer like myself also experienced this in the 1990s as the internet lowered the cost of distribution, communication, and search. Industries disappeared, industries sprang up, and culture changed. Okay, now we're getting to the part that hits home with us. Why does any of this have to do with artists, with designers? Why should we care about this technology? So I would put to you first that the technology needs us. The technology needs human-centered research methods. So designers are trained to seek a desired future, or the right thing to design. Data scientists, on the other hand, are trained to seek what can be accurately determined from the data at hand. So to put this another way, let's imagine that a designer and a data scientist are giving a dinner party. So the data scientist would approach the meal for that party by thinking first about the ingredients. What ingredients are at hand? What ingredients are fresh, convenient? And they would build their meal around the ingredients. The designer, on the other hand, would think, who's coming to this party? What are they allergic to? What do they particularly like? What kind of experience do I want to build around this meal? And they would construct their meal plan that way. So I would suggest that we need both of those perspectives. And if we don't have both of those perspectives, then we're going to end up with a lot of meals that nobody wants to eat and that perhaps could be really destructive to us or unhealthy for us as well. Okay, so the technology needs us, our human-centered perspective, but we can also design really interesting things with this. So first of all, we can begin to think about designing individualized experiences. So experiences that are useful, usable, and desirable, to use Liz Sanders' terms, but to a specific person at a particular moment in time. This is a project created by grad students at NC State, where I teach. And I am going to show you a lot of student projects because that seems appropriate, I think. So this is a project that they did a big project in collaboration with an auto parts company. This is a small piece of it. This is a predictive maintenance app that anticipates customers' maintenance needs for their vehicles years in advance, so they can be addressed before the needs actually appear. This is a big issue right now in healthcare. In healthcare, we're beginning to think about predictive medicine. So predicting a illness or some kind of medical condition before the symptoms appear. And as designers, that's interesting for us because how do you communicate that to someone? This is another grad student project. This is a project by Rachel Payne in collaboration with the computer science department. She did research on caretakers of kids with rare diseases. And she found that when children are first diagnosed, the thing that their caretaker does immediately is they start to do a Google search. That's their number one go-to. I need to find out about this disease. And when they do that, they're accosted by all kinds of information that they're not emotionally ready to handle, like end-of-life care. So she worked with a team to create this intelligent hub. And the idea behind the hub is that when you come to the interface, it presents to you only the information relevant to your child's particular rare disease at the phase of the illness in which they are experiencing it. This is another less admirable example, McDonald's intelligent digital menu. This is a menu that identifies you and then on the fly creates a special combo deal for you. So let's say you pull up and it identifies you and says, hey, we know that you love bacon, egg, and cheese biscuits. So we're going to create a special combo deal just for you around the things that you like. And we're going to throw in some iced coffee because it's really hot this afternoon. And we know you enjoy drinking coffee mid-afternoon. So fast food getting faster, not quite perhaps such a great thing. Okay, so the examples I'm giving you are examples of anticipatory design. So thinking about design in which no direct user input is required. The system is anticipating the user needs before they ask for something. Here's another project illustrating this. This is another grad student project. This is a project in collaboration with Watson Health. This was, in this project, the students prototyped a wearable device for individuals with cochlear implants. They found that if you have a cochlear implant, you are highly impacted by the casual lunches that people have in the workplace, because those lunches are, a lot of decisions are made, a lot of social bonds are formed, and it's really, really difficult to hear in those unpredictable spaces. So they prototyped a wearable that would take all of the features or all of the conditions of those situations into account. What's the noise level? What's the room size? How many people are you talking to? What's the conversation structure? Is it more one-on-one, a larger group conversing together? And then through Bluetooth, instruct the cochlear implants to optimize the microphones for different settings as the conditions change to optimize the hearing. In essence, what I'm describing to you is a difference between do it for me or do it for myself. So Grammarly is another example. Grammarly offers a phrasal prediction feature. And this is, Google Docs does this too, not quite as well, but the feature is designed to learn your phrasing style and then suggest phrases to complete your sentences as you're writing to move you through the writing process a little differently. Now, this brings up some interesting questions for us when we begin to think of this idea of do it for me or do it for myself. And one of those issues is de-skilling. So as a designer, as a culture, what skills do we want to keep and as humans, and what skills do we want to automate? That's a tough question. So here's an example, Google Maps, right? When you're using Google Maps, the system is designed to very efficiently and conveniently get you from point A to point B. But it could be designed differently. Maybe you don't always want to just get to point A to point B. Maybe sometimes you want to be taught how to get there yourself without the device. Patty Meese runs a group at MIT, the MIT Fluid Interface Group, and they think about this topic a lot. How do we create tools that build skills within us so that when we put the tool aside, the skills are then stronger within us? You could also think about this as the difference between a scaffolding tool or a crutch tool. So they've done lots of projects. This is one of their projects. These are AR glasses that use this ancient idea of the memory palace to teach, and so while you're wearing the devices, you're moving through space and you're memorizing information. But when you put the device down, that information is retained and that memory skill is strengthened. Okay, so I've talked about this idea of anticipatory design and de-skilling. Now I'm going to shift a little bit and talk about how machine learning is changing how humans relate to machines and how that affects what we design. So there's two types of technology enabled by machine learning that have particular impact in this space. One is natural language processing and one is computer vision. Natural language processing is the ability of a computer to analyze, comprehend, and generate text. Computer vision, similar, but here it's a computer's ability to identify and analyze images. I'm not going to talk about computer vision much, but it has a lot of impact on, for example, being able to communicate with a machine using gesture or movement or expression. But I am going to talk a little bit about natural language processing. This is a quote by Sherry Turkle. Machines with voices have a particular power to make us feel understood. We as humans for thousands of years have been conditioned to expect anything that speaks to us using human language to be another human. Researchers Clifford Noss and Scott Brave wrote a wonderful book called Wired for Speech. And in this book, they conducted study after study to try to determine if we bring the same biases and cultural associations to interactions with synthetic voices that we do when we're interacting with other humans. And they found that even when the voice is very, very obviously robotic and synthetic, and even when we are consciously attempting to suppress those attitudes, we still bring them to the experience. And this matters because we are increasingly talking to machines. In 2014, Facebook's self-care chatbot Wobot was receiving 2 million conversations a week. Amazon had sold 100 million Alexa devices. In 2020, hundreds of thousands of people were each sending around 70 messages daily to Replica, an AI companion that learns your personality and sort of mimics it back to you in the form of a companion. Microsoft Xiao Ice, a popular social chatbot, has over 660 million users, primarily in China. All of these humans interacting with machines through language also raises questions. How might these relationships open us up to manipulation if we're bringing these human expectations to the experience? In whose interests are these relationships being formed? You could ask, who is Alexa really working for? Is she working for you? I don't think so. Okay, so this is a quick little study that one of our grad students did, playing around with this idea of chatbots or any kind of virtual agent, conversational interface, manipulating emotions. So in this study, she created this little character Bebop. And when you speak to Bebop in a way that Bebop doesn't like, so you're not phrasing the request using the right type of phrasing or language or anything, you hurt Bebop. So he gets a black eye or his arm breaks. And eventually, if you speak to Bebop incorrectly, Bebop just dies. So it's playing with this notion of emotional manipulation. So we can think about how language is changing our interactions with machines and the questions that are raised there. We can also think about how that might in return change the way we interact with one another. Another Sherry Turkle quote, even as we treat machines as if they were almost human, we develop habits that have us treating human beings as almost machines. The theorist Yuval Harari has also brought up this query. What happens when your refrigerator is more attuned to emotions than your partner is? Now, right now, you might be thinking, well, then why are we doing it? Why don't we avoid this? This is obviously tricky terrain. Why don't we avoid these kinds of social, emotional connections with machine through language and other technology? Well, I would put to you that we can't really do that. This is a quote by AI researcher Sabaro Kumbampati. If we do not focus on creating machines with an adroit social, emotional intelligence, we'll end up with computers that don't understand us and don't need us. If we really want to collaborate with machines, and I would suggest that we do, and I'm going to talk about that a little bit more in a minute, we have to establish these kinds of social, emotional relationships with them because we're human and that's the way we work. But this is hard to do. It's easy to get this wrong. Microsoft introduced Clippy in 1997. People really disliked Clippy. Clippy was very annoying. Clippy was not enabled by machine learning. It was not intelligent, but it was a version of an early idea of a virtual agent. So Clippy was annoying because Clippy was always peppy and seemed kind of smug. And trying to connect with when the social emotional responses are off is really exhausting. So this is very difficult to get right. This is a project by the studio Telart working with Toyota's advanced design team. This was a project exploring this idea. And in this case, they were exploring autonomous vehicles. And how do we create emotionally intelligent autonomous vehicles? What is that experience like? What is that interface like? Okay, now I'm getting to a question that artists and designers always ask, right? Because this affects us very deeply. How might machine learning change not just what we design, but how we design? How might it affect our design process? This is a tool built by Sharif Shamim. This is a tool that allows users to generate the code for a fully functioning app just by describing it. And this is interesting because language is being used to design the front end, but simultaneously the back end. You can take this and begin to think about language as a design tool, right? Imagine describing or using language to design. And you can start out simple, make the sky bluer, add in the green or something, make it bigger. But then you can look to the next step, right? Add more tension, add more white space, we're beginning to codify the design process in ways that will have a deep effect. So that's an interesting piece of it. But we can also think about language, and I'll go back to image recognition and using gesture language to design. Maybe the very idea of a tool, the way we think of it, whether it's a mouse or a click pad or even a pencil that we're drawing on a tablet with, maybe the very idea of a tool will become irrelevant and our design process will feel more like a natural extension of ourselves through the way we naturally communicate. Okay, so how else will machine learning impact design practice? Patrick Hebron, the director of machine intelligence at Adobe, talks about this in terms of scaffolding complexity. So he gives this example of the Florence Cathedral that from concept to completion took 140 years. And juxtaposing that against the Burj Khalifa, much more complex building that took 5 years. So he likes to say that machine intelligence will enable creatives to do even more and think even bigger. to work with complexity in a way that was impossible for us in previous generations. One way that we often think about computation and the possibilities of computation around process, kind of a go-to is thinking about breaking down designs into lots of parameters that could be reconfigured by the computer. So we can look at lots of variations and just kind of pick what we want. This is an example from Carl Gerstner's 1964 Designing Programs, which is a book actually that Ellen introduced to me, so I'll throw that in. But we see this today evolving through this idea, evolving through GAN systems, so general adversarial networks. And what I want you to remember about GAN systems is that they are generative. These are machine learning enabled systems. They're in essence 2 neural nets. But what's interesting for us is that using a GAN system, you can create new data instances that resemble the training data, but are different. And there are quite a few tools that allow designers to engage with this technology easily, like ArtBreeder, Runway ML. There are others as well. Here's a project led by Anastasia Reyna at RISD. And in this project, the images that you're seeing are generated from a data set of 2,000 images of marine invertebrate zooplanktons. So these are images that do not exist in real life. They are similar to the training set, real zooplanktons, but different, unique. And a different perspective is being brought to form here that the designer themselves would probably not have come up with if they just sat down to draw these forms. So this different perspective is perhaps the most powerful way of thinking about machine learning impacting our practice. Janelle Shane, who is a data researcher she wrote a wonderful book called You Look Like a Thing and I Love You. And she's very funny, so I would encourage you to check her out if you are interested in this topic. But she suggests that working with AI is a lot less like working with another human and a lot more like working with some weird force of nature. So this is an example that she gives. Google Ha, who is on the Google Brain team, he created a study in which he asked an AI to assemble some parts into a robot to move from point A to point B. And obviously he was interested in how the robot might very efficiently create this form that could move from point A to point B. But what happened in reality was that the AI combined all the parts of the robot into a big, tall tower that could just fall over and land on point B. So very different perspective in how to solve the problem. But we need to be careful about when we seek this other perspective and how we seek it. So Patrick Hebron suggests that if we want human thinking, we should probably go to humans for it. There are a lot of them. So we shouldn't try to force AI to think like humans. We should embrace the alien thinking that AI provides and work with that alien thinking. But as I mentioned a few minutes ago, we have to be careful when we do this because just as the AI built the big tower, AI has no understanding of consequences. And this goes back to humans bring that understanding to this process. It's very important for us to be involved because we bring that understanding of context and consequences. And consequences matter because these systems have many, many critical issues around bias, privacy, manipulation, surveillance, amplifying problems that already exist in our society. I'm not going to go into all of these. This is a whole nother lecture or series of lectures, but I am going to briefly just touch on some designers working in this space having a lot of impact. Because this is another way to think about how artists and designers might relate to the technology. This is Joy Buolamwini's Algorithmic Justice League, which she founded to fight the coded gaze. So bias that she uncovered in facial recognition systems around gender and skin tone. Sarah Gold in the studio IF in the UK, working very hard to lead creative teams to address ethical issues around collecting and using people's data. And she has created a whole library of interaction design patterns to help address this issue that you can access. Data scientist Stephanie Yee and interactive designer Tony Chu, founders of R2D3, they created a wonderful interactive visualization that you can move through online that helps you understand how a type of machine learning model, a decision tree, works. So thinking about using visualization to help people really understand what's going on in these black boxes, what's happening in these systems. Mimi Oniowa has created and is launching an exhibition right now, but this is a wonderful installation of hers in which she draws our attention not to the data that's being collected, but the data that's not being collected. Mimi also worked with Diana Nucera in Detroit, also known as Mother Cyborg, to create this zine that introduces to everyday members of the community, introduces AI to them. And they created the zine, and they also led a series of workshops in different communities. And their idea was, this is a way to introduce AI to individuals and suggest to them that they can contribute to an equitable technological future. So educate them around their digital rights and give them that power. I'll wrap up my talk with this idea that machine learning can prey on those that our society already victimizes, or we can get involved and use the technology as a mechanism for equity and justice. And there are a lot of designers and artists out there doing that right now, and it's really, really needed. We shouldn't trust a technology that has no understanding of human consequence to take the lead. We've got to take the lead. We can't just sit back. We need to be involved. And I would encourage you not to let this technology intimidate you, because your skills and vision as designers are really, really needed. As Vesna mentioned, I do have a new book out, Big Data, Big Design. So if you're interested in the topic, feel free to check it out. And that's it. Thank you.
Thank you. That was so beautiful. I was really curious the work you're doing around health and accessibility at NC State. Can you explain a little more the project for caregivers of children with rare diseases, how that uses AI? Thanks.
That's so funny. I knew you were going to ask that question. So that's using AI in a pretty simple form. It's just classification. So it's creating buckets ahead of time that the researchers identified, and then putting people into those buckets as they arrive in the site. Now, how they're tracking the behavior of the individuals before they arrive to know at what phase of the disease that they're in, that might be what you're wondering. And that I would have to have Rachel talk to you about, because she's the designer who worked with the research team on the project. So I'm not sure how they're tracking behavior to arrive at that determination, but once you get there, they're just putting you into buckets, lots of different buckets for all these different diseases and the different phases of the diseases. And the reason why that's valuable for that particular group is that they're very rare diseases. So it's difficult for those caretakers to get to that essential information quickly, but it's because the research is so outside of the hub, is so distributed in lots of different locations. You're welcome.
So there we go. I was wondering if you see
within this new technology a lot more push towards localized solutions or like generalized? And like where is it coming from? Like there are a lot of solutions that could be across the board where it's like, okay, people want this, but like if you go to another community, that's not correct, right? If that makes sense.
Yes, that makes perfect sense. And so I would say it opens the opportunity for localized solutions. And there is a push for thinking about data and communities and local communities and how data and machine learning might specifically be collected and utilized to address the desires of the local community rather than the larger society. So I did a project last semester with Red Hat, which is a enterprise level software company in Raleigh. And the project was around autonomous vehicles, and they were interested. They're an open source company, and they were interested and they're kind of getting into the autonomous vehicle space. And they were interested in thinking about autonomous vehicles as so if you think about an autonomous vehicle, it's collecting tons of data all the time. It has to in order to operate. And so they were thinking, is there a way these vehicles could be collecting data in local communities and then giving it back to the community to benefit the community in different ways and address different issues that they had? So yes, I would say that it's opening the door to this notion of localization in interesting new ways.
Awesome. Thank you.
Hi, I'm Cole. I just want to say thank you for speaking and enjoyed your talk. I read your piece, Seize the Data, and used it for one of my classes. And you have this quote that I like. You said, if social emotional intelligence proves crucial for future human-computer relations, perhaps designers should begin to consider in what contexts such emotional intelligence might or might not be appropriate. And I was, I guess, curious about which contexts you refer to that are not appropriate, and maybe like moving forward in an academic sense, I guess, under institutions, like how do you begin that conversation to students, like to prepare them for raising awareness of inappropriate contexts or biases, I guess. Yeah. Does that make sense?
No, that's a great question. Thank you for the question, Cole. That's a good, so so there are different answers to that. The first Kate Crawford is an AI researcher who has done a lot of wonderful work around thinking about context and framing for those kinds of social emotional relationships. She's at the NYU AI Now Institute. So I would point you to her and some of the papers that she's written because they're really fascinating. And what she explores is when a social emotional relationship can be damaging. She looks a lot at robotics, so intelligence robotics. So examples she gives for here's one that in a hospital setting, she visited a hospital and they had this very rudimentary robot that would go around and dispense medicine to people. I mean, it had a level of intelligence, it had a lot of sensors and it kind of understood context. So it had some intelligence, but people got really angry at this thing. It looked kind of like a big box on wheels and they would push it and hit it and yell at it and get really frustrated. So she came into the situation and she simply suggested that they give these robots names and backstories. So she gave so they started every robot that they sent out, they began to give it a name and a backstory. And they saw a dramatic improvement in the way people treated these robots because they suddenly started to give them personalities and identities. And in that situation, it was appropriate because they needed that robot to move through the the hospital space without being damaged. They needed people's patience because the medicine was important, that it was distributed, et cetera. She gives a contrasting example of this is again a robot example, but it was a kind of robotic dog that would go out and set off bombs, mines, so that to protect the humans. But the robot looked a little too much like a dog, and the soldiers found it to be emotional torture to send these creatures out and then watch them be blown to bits, or watch them like try to drag themselves back with like 2 broken limbs or whatever. So in that context, it was a huge mistake to create this social emotional relationship because it was painful and damaging. So those are examples of thinking about, when is this appropriate and when is this not appropriate? What is the kind of interaction that you really want to be happening here as the person that is using it? And does it serve that purpose, your purpose as a human, to forge those relationships, or does it work against whatever that purpose is? Does that answer the question? Okay, you're welcome.
Hi, Helen. Thank you so much for your wonderful talk. Among many very important slides, I really like the juxtaposition between designer and then data scientist, right? And then you also mentioned about how human and as a designer would create new relationship with the machine. So my question is about how then designer would build a new relationship with the users, because in consideration of the difference between designer and then data scientist, one of the very big difference comes from the consideration of users, right? That you said that users just feed all the system generating the data, right? But users are more than that. So how do you see that the kind of future relationship, or what we, the designers, have to consider in relation with the user?
Okay, so there's 2 things I'll say there. One is that we have seen, in the last decade or so, moving more and more in this, being more aware of the humans that are using the system and creating methods for understanding, empathizing, and co-creating with them, right? So we've sort of been on that train for a while, and it's great that we have been, because we need to be there to take on these complex systems. I do think that our responsibility to those humans is greater than it has ever been, because the damage that we can do is so much bigger and wider. So that's a little scary, that's a lot of responsibility. But I think our awareness is, we're becoming more and more aware of that and being very thoughtful in how we address that. So that's one thing. The other thing I would say is that because sensors allow us to also better understand the non-human world, I think so this sort of post-human perspective is really interesting too. So the idea that the user of the system is not necessarily a human, and that trying to use the data to better understand the non-human world and design for that world. There's a lot of energy in that space right now, and I think that's really fascinating too. So not leaving the humans behind, but expanding our understanding through the data.
Thank you, Helen. We have a question from a webinar viewer over here. So Sarah Baker asks, hello, not sure if, oh, never mind. I wanted to ask, do you have any sense of how many designers are actually embracing GANs, G-A-N? I'm using it in my own graduate research, but how widely used are they?
That's a good question. I don't have a sense other than my own experiences. So my own biased perspective. So it's pretty, the generative adversarial networks. Yes. So systems that are generative in the sense that they can generate new data that's similar but not the same as the training data. So it's There are a lot, I mean, there are some really some big names in this space kind of emerging. I personally have seen it taking off with people that I've spoken to. I know my own students were familiar with it and working with it before they came to my class. But I don't have, I can't give you a good sense overall of how many people, but I would also suggest that the fact that there are platforms out there and there are new platforms popping up every day would be a sign that more and more people are going interested in engaging with fan systems.
Hi, it's on, or should I just talk loud? Is this better? There we go. So this might be more of a discussion. So I was just wondering if you had more thoughts on kind of the handoff between you're talking about de-skilling with certain machine learning and how some of the examples you showed, like for example, we use a GPS, we're not really learning how to get there, but that's kind of more useful and we have to get places quickly and such. But with some of the health examples you were showing, we're not really learning those skills, but obviously the information is more critical. And I was just wondering if you had more thoughts on that and what fields you think it's more important to either learn those skills or just get the information and not necessarily learn how to do those things yourself.
So that's a great question. And I think that is more of a discussion, but I would say, I think it's completely context driven, right? Whether or not it's appropriate, I don't think these are blanket decisions that we're making. We're looking at exactly what we're making in what context and for who, and then deciding if it's appropriate to automate that skill or not. So to go back to your GPS, yes, if I'm coming into a new city and I'm only going to be there for a day, maybe I don't want to know how to get from A to B. Maybe I just want to get there fast, and that's appropriate. But maybe I would like the option sometimes to learn how to get from A to B, because it's actually more efficient for me to have a mental map of the city that I live in and be able to move around through that mental model. So I think the answer, it's a great question. And I think it's more of the kind of question that we should just keep asking ourselves with each thing that we're making. And not as, I think the big takeaway is don't assume that we should go to automation immediately, because convenience and efficiency are good ways to make money, but they're not necessarily the appropriate solution to every problem, right? And we should be the ones that are in the room saying, wait a minute, maybe we should rethink this feature a little bit, because let's step back and think about the impact of what we're doing here. And so just raising those questions is really important. And I think we're responsible for that.
Hi, thank you so much for your talk. So I also read Seize the Data last term, which was awesome to read. And I understand the need to push beyond transactional and informational, but I'm wondering, what are the benefits of creating emotional relationships with AI beyond like building a trust between machine and human?
I would say right now, so that is a fabulous question. And I think it's a question that's going to take on more and more relevance in, the next, I don't know, right now it's taking on more and more relevance. I think the answer to that is it's not just us creating these kind of emotional relationships with the machines, but also the machines creating emotional relationships with us. And I don't mean this in a, sci-fi general intelligence singularity kind of way. I just mean that if we're having these kinds of exchanges, they have to, from our perspective, seem to also get the kind of emotional. So there's a quote, I can't think of her name all of a sudden, but there's a nice quote that from someone I interviewed in the book. And the quote was something like, we can't just show empathy we can't just create experiences in which we are showing empathy toward the machines. So that's, we're designing for that, but also so the machines are showing empathy to us and designing the experiences in which they would be able to do that. And I think that is just super interesting. How do we do that? And where is it appropriate to do that? And where is it not appropriate? So I think maybe I'm kind of going around here, but I think trust is very important. But also, well, I think trust is very important, and trust leads to lots of things, right? It does lead to collaboration. It leads to conversations. I just had a researcher from CMU visit my class last week to talk about Paul Pangera, who's wonderful and has this great discussions around the potential of conversation and conversational exchange with the machines. And one of the things he says is that conversation always begins with trust, right? We establish common ground, we're working toward a goal. So I don't think we can underestimate the power of trust in these sorts of relationships we're building with machines. Does that answer your question? I kind of went a little round and round, but yeah, you can follow up. Okay.
It's me again. I guess I don't know. AI, very broadly speaking, I think for me, or maybe before some of the readings I've done, including yours, like it's a very abstract idea, when in reality, like a lot of what you're saying is like it's really kind of just it's humans, it's us, essentially. It's not like a separate entity. It's not like an autonomous, I mean, technically speaking, thing, right? Like we're informing it or training it, as you say. There's like this part, I think, in Seize the Data where you talk about how this relationship, right? This like that we have with AI or computers or something, like how it can actually enhance not a relationship with them, but with one another, with human to human connection. And I feel like that was really interesting to me because when you think of AI, again, it's very abstract and it seems separate I guess what I'm getting at is like how, as an educator, like how do you foster, like, aside from just providing textual information and discussion, like maybe like under a school setting, how do you like help students realize that it's not this like separate abstract entity and it's actually very tangible and real and accessible, and it's not just a bunch of zeros and ones, and like you have a lot more agency to play a part, have a role in that process, I guess. Does this make sense?
Yes, it does make sense. So I think there are a lot of different answers to that. One answer is to start investigating all the designers that are working in this space, because I think that's very inspirational to look at the projects that they're doing, because that gives you an idea of the kind of ways that you could engage with this technology too. And it goes from really low tech to really high tech. Like I would consider GAN systems to be pretty high tech, actually very accessible if you start playing with those platforms, but more on the high techy end. But then the AI zine that I pointed out, which is just a great zine, and I should have mentioned, you can download it for free. So I would encourage, I'll share my slides. I would encourage that because it's a really fun, interactive kind of workbooky, what is AI experience. That's a really low tech experience, but think of the power that has to go into a community and people walk out and actually have a sense of how the technology works and how it might be impacting their lives. Because when we think about the impacts, it's just so, my own students are experiencing this a lot in hiring practices right now, right? You're being screened by an AI into two buckets, like the viable candidate bucket and the not viable candidate bucket. And it's impacting whether or not you get a loan. It's impacting, whether or not people go to jail or not, or whether they get, I mean, these are like heavy impacts. So raising the level of understanding and raising people's awareness of their digital rights is, I would say, one of the crucial issues of the moment for our society. There's so many things we can do, Yes, we can make zines, we can visualize these models so that people can engage with them and play with them. We can think about different patterns of interaction and all these. I mean, I think we can touch on this in so many different spaces. So I think it's more about just introducing it to people and letting them, go to town, because there are resources out there. Another resource I would put out there is Google Pair, P-A-I-R. Google Teachable Machine. That's a really simple way to interact and play with the technology. And it's a really good way to start understanding simple machine learning models like classification models.
So like, yeah, that's so cool. And the zine thing I've loved. I thought that was really, really interesting. And just like, yeah, seems like you said, accessible. I think it's really important to like empower, especially like younger generations, right? Like, it's an empowering thing to like, when they're coming up in this day and age, and then they're just gonna like, the second they realize they're surrounded by AI and they're just like, what is that? I think like working within familiar formats early on is something that intrigues me. And yeah, so anyways, thank you. I appreciate that response.
You're welcome. I'm gonna pull that zine back up. Here it is.
So you were talking about how like AI could possibly be used to like judge if someone should go to jail or not. So how do we know that whoever's building these machines is doing so from a place of like no bias? Because there's probably a lot of hateful people who could like use this to their advantage. I mean, I've heard of like algorithms like turning people to like QAnon and like all these like crazy sides of the internet. So how do we know that basically like nothing bad will come from this? Or how could we take steps to?
Okay, those are great
And
questions.
actually, Helen, if I may add to Loli's amazing question, you and I once read a book by an author called Douglas Rushkoff, who it was titled, or it was a phrase, it goes like this: you can either program or you can be programmed. How do you build critical thinking in the age of artificial intelligence and machine learning?
So the question that you're asking, first, I'm going to go back to the first segment, which is how can we build these systems that aren't biased? And the answer to that first is we can't, right? We can't erase bias from these systems because we're creating the systems and we are biased. So we're always going to have to be auditing, and there are efforts by the tech world and the non-tech world to audit these systems and make them more transparent and more culpable for that bias. So actually, another student project. So my students are working on a project right now with a company called SAS Analytics. I guess I could say, I don't think. So, and that project is around AI ethics and thinking about creating interfaces and experiences that make these systems auditable. So, go back to who trained it, where they trained it, how much they trained it. And this actually is it's not an unusual idea. People talk about it like nutrition labels on, putting nutrition labels on machine learning systems so that we can understand what's happening more. IBM also has a big endeavor in that space. So there are initiatives underway to make these systems more transparent and to catch this bias. But I think the takeaway is it's not going to go away, and we have to constantly be wary and work at it because they have enormous power. And it's not like we're going to make one little label that explains the data and the bias, the problems are going to keep reemerging. So we have to really be on our toes as we start using these systems. And they're already here, so we really need to engage and not be swept away on this train of, bias and black boxes that we can't understand. We have to get on board. And I want to say one more little thing on that too. Sorry, this. Social scientists are also really, really important in this domain. And so for designers also to begin to work with experts in ethics, right? Because we're not experts in that area. To take on these systems is also really important and powerful.
So that is a wonderful teachable moment to end on, and it leaves us with a lot of thoughts. I would like to thank Helen for an amazing presentation, and to each of you for your wonderful questions.
And thanks for having me. It was really fun.
Just a tiny note that the the lecture has been recorded, and we will make it available to the campus community. So you can, go back and check on things that you were excited about, but you may have, missed the first time around. And also, if anybody has any copies of Ellen's books or articles, she will be available upstairs for signing or for some short additional chatting before the official end of the event. So thank you so much for coming, making the time to get out of your busy schedules and attend this lecture.